So it's about time to try some differentiation to prepare for your DSE or IB or GSE, whatever. So let's try this exercise first. Now we have some water. It is pumped at a rate of 4.5 liter per minute in a right circular conical tank, which is right means it's exactly perpendicular at the top. So the depth is 60 cm and its radius is 45 cm at the top. That is a cone with the bottom facing upward. So now we have a question for you. We want to know exactly what is the rate when the water level is 40 cm depth, so 40 cm deep. So let's calculate. First of all, let me draw the diagram first. So you have exactly an upside down cone. So you have the radius of 45 and also you have the total height of 60. So first of all, we have to state our variables. So this is I call h, and for the height I call it h. Now the question would be, I want to find dh, dv, dt. Now this is not what I want to find, this is stated. So this is 4.5 liter per minute. And what I want to find is dh dt. What is the rate of change of the height? So this is what I want to know. This is known, this is unknown. So in order to get to this one, we need to use the chain rule. Now if you remember, the chain rules say something like you have the dv dt, and these derivatives can be written into a form of chain. So you have the dh dt. Okay, so this is known, this is what we are asking for. So if I calculate dv dh, then I can solve the problem. So now dv dh, so I have first of all I need to formulate an equation for v. So v, if you remember, this is the right conical shape. So I have a third of the base, which is the top now, and times h. The problem with this equation is we have two unknowns or two variables. Okay, so if we have two variables, then we have to strike out, eliminate one before we move on. So we have, first of all, we need to eliminate the r. Fortunately, we have the ratio for r. It's given that r divided by h is equal to 45 divided by 60. So now I can have an equation for r. R can be written as, so this is a quarter, so you have 3/4 of h. Okay, so r can be written in form of h. and so we put back this let's say this is equation 2, this is equation 1. Now we substitute the equation 1 2, substitute 2 to 1. So I have V equals to a third of 3/4 h squared times h. So I can rewrite a form h cube. Okay, so now I can differentiate dv upon dh. So I have now for differentiate, let's say ax cubed dx, you have 3ax squared. Remember that. So exactly the same thing happened over here. So you have another 3 times 3, and then you have the h squared. Now I have a perfect equation for dv dh. So now I move back to what I started. So I have an equation over here. So I remember this equation. So I have 4.5. Remember, this is liter. So in order to have the same unit as the h or the r, now you have to multiply by 1,000. Why we need to multiply by 1,000? Remember the 1 liter. 1 liter. 1 liter equals to 1,000 cm cube. Okay, so that's the reason why we need to multiply by 1,000. So now I have this is dv dt, dv dh, and dt. So easy. 4.5 times 1,000 equal to, now we have this equation over here. Okay, so it's 916 h squared and times dh dt. Now what we are going to do is we put all the extras to one side and then rewrite this equation like this one. So you have 4.5 times 1,000 times 16 divided by 9 pi h squared. Now the equation states that when h equals to 40, what is the rate for the dx dt? So put the h back to the equation. Okay, so we have the back to the equation. So we have times 1,000 times 16 times pi divided by pi, and then this is 40 square. If I'm correct, my calculation is correct, you have the per minute. Okay, so it's the end of the tutorial. I hope you enjoy it. Bye.